We'll review for either 2 or 3 days, and then we'll take the unit 8 test, and then after we get back, we'll start with just overall review for the AP test. So let's go ahead and start on this review. Work through this next couple days. I don't think the new content on this isn't really, I don't think that difficult. Kind of like the last unit, as long as you knew like slope fields and differential equations are like the two things. This is really just volume and average value. That's about it. The new stuff shouldn't take that long to get through. And then it's just going to be some review, like here's unit velocity acceleration. Here's there's some Riemann sums more in this one as well. And then we've got some discontinuities, limits, things like that, which are just overall review. So really the new stuff isn't that much. So we'll see. Maybe just 2 days of review, we'll see what you guys want to do. All right, so let's go ahead and answer the first one. Supposed to use the graph in the table to the right to answer this question. First one, show an integral setup for the average density of hikers between miles 1 and 5. So the key word in this, it's very subtle, but it's where they can get you on the AP test. What's like the one key word in here? In this first sentence, what's the key word? Huh? No. Average, yeah. So the key word is average. The reason why that's the key word is because average is telling you we don't want to just show the overall distance, the average density, which means we're going to need to do a 1 over b minus a, and then the integral. So anytime you see average value, this is the case average density is the value, then you want to do the 1 over b minus a. So that's the key word, and it's in all of these average. So whenever you see that average, you got to think the average value, this f average. And it's solved exactly the same as anything we've done before, it's just got to do 1 over b minus a in front of it. So let's set up an integral, average density of hikers. And if it was just the density of hikers, like total amount, then we would just do the integral. But since this is the average, we got to do the 1 over b minus a. So we just want to make sure we use the right notation. This function they're calling big D of x. So don't call it f of x, it's called big D of x. All that. So we 1 over, we're going 1 to 5, so 1 over 5 minus 1. Integral from 1 to 5. Big D of x dx. But then part 2 asks us to use a midpoint Riemann sum to do the same average density. So we're going to do the same idea, except Riemann sums are ways of just like approximating integrals. So instead of doing the integral, we're just going to do the Riemann sum. So let's go ahead and do that. We actually need to add an answer for this one. So we'll start with 1 over 5 minus 1. You can start 1 not equals times. And then we're supposed to do a midpoint Riemann sum with n equals 2. So we're only going to have 2 sections. We're going from 1 to 5. And it gives us the table down there as well. So what values are we going to be using here? When you think of Riemann sums, think of it, it's always rectangles. So it's always like a length or width times a height. Right? So what's the width of these intervals? We're going here, and we're going to divide it 2. Yeah, so 3 here is kind of natural division, right? Well, the easiest to see on the graph. And then, so since it's a midpoint, we want to find the middle of that integral, and that's going to represent our height. So this is really this. Didn't ask us to draw it, but helpful to see it this way. And then this other one's going to be 4 is going to give us the midpoint. And drawing it can help you figure out how to write these as well. And then if you just look at each of those rectangles, what the width of each of those are, and then what the height is. So the first one has a width of 2, right? So it's going to be 2 times, and then the height at 2, and look here just to verify it's 35. So 2 times 35, plus the next one is a width of 2 as well. And the height at 4. So we get 70 plus 50, 120, so 1/4 times 120. 30. Now, since this is a word problem, we're going to make sure we get the correct units for this. So that will be worth like a half point or something. So what do we find here? Yeah, good. So hikers from what? Yeah, and then this one, the trailheads, you can put that, so you don't do it as well then. I think that it's actually, yeah, growing up from trailheads. So this is saying the average density is 30 hikers per, not male, miles. Hikers per mile. 3, 4 equal with trapezoids to approximate this average density on the same interval. Right. Go back to our trapezoidal Riemann sum. You can remember how to do that. And again, it can be helpful to draw it as well, especially if you don't remember the exact formula, which there's a good chance you might not remember at AP test. So let's go ahead and draw it here. So it's supposed to be 4 equal ones. Well, we got 1, 5, so that makes sense. There seems to be 4 logical divisions. And then so each trapezoid will go up and over like that. But that's going to be a pretty good approximation. And we need to keep this 1 over b minus a, so we'll have the 1/4 in front. And then if you can remember the trapezoid area formula, which is 1/2 b1 plus b2 times the height, and just do all of them sort of like that. But if you remember, the half can pull out in front because they're all going to have a half in it, right? 1/2 b1 plus b2 height, so you can pull that half in front. And then so it's going to be for each one. It might even be easier if you just went ahead and wrote that as 1/8. Less confusion. So then you got b1 plus b2 times the height. The height of each of these, actually you can pull out as well, because the height is just 1, right? So we don't really even need to write that. I suppose maybe on the AP test, just to show that you're doing this right, this is how I might do it. Do like 1/2 times 1, just to show that you're including that, right? So that you know what you're doing. And then we just have all of the b1 plus b2s. And there was also this shortcut that we used when we did trapezoids, where so the outer ones, they're only going to use 1 time, whereas the inner ones know how they get doubled. So you could do that as well. You could write as the first one is going to be 40 plus, and then 35 gets used twice plus 2 times 30 2 times 25 plus all. And then so I would write this just as 1/8 out. And then we've got 40 and 70 is 110 plus 60 is 170 plus 50 is 240 plus 30 is 240. One eight, 240, 240. What you guys think? All right, and then we're supposed to estimate where the trail density is equal to the same average density. Well, that's pretty easy. Where, at what point, at what mileage? Yeah, because that's we got a table to tell us that too. So x equals 3 miles. And then last one, write a complete sentence using numbers and units to tell what the integral from 1 to 5 of d of x dx. So this one's not an average because it doesn't have that 1 over b minus a. Generally, when you have an integral, it represents like the total amount, the total number, right? So something like that. What do you guys want to describe? Integral of 1 over so the total number of hikers, probably, right? Total number of hikers. And that's at basically 1 to 5 miles from the trail, right? And this is something we'll practice once we get back from spring break, where we have a month to practice. We'll do a bunch of free response questions, and like the ones that they've released, they release a certain number of AP questions every year. I think recently they've been actually doing all of the multiple choice ones, like in the previous year, they'll release them. And they generally release the scoring guide too, so we can like do the question, and then we can actually pull up the scoring guide what they use to score it, and so you can start to see like what they're looking for in their answers and practice the exact format of that a little bit more. So the last month will be more tailored to this is exactly how the AP wants you to write it. Whereas like most of the stuff we've learned to this point, it has been all of the content of what's on the AP test, but it's not necessarily like every single question isn't necessarily like must be on the AP test. It's kind of geared that way. So number 6, set up an integral which could be used to find the area bounded by these two graphs. So the equation is used to find the limits of integration. So we gotta set it up but not integrate it. We also need to show I found the limits. So how are we gonna find the limits? Let's go do that first. Yeah. So we need to set them equal to each other, right? Yeah. So let's go do that. And I'll give you guys a couple minutes, see if you can factor that. Should be 2 and -1. You're good. That one didn't end up being too bad because you could block the 2. I was actually kind of hoping that you would have to factor with the number in front of it. Didn't work out. Okay, now we gotta set it up. So you can't use your calculator. You could try to graph this, but it doesn't say we have to sketch it. The only thing that you got to make sure on is when you're doing the area between two curves is you do the top function minus the bottom function. So you got to know which of these two is the top function. Which do you think is the top one? Okay, why do you say that? Okay, so you just plug the number in the middle of the interval and then f of x would be. Okay, that'd be one way to do it. Yeah.
That's reflective, so it's like don't back, but down.
Uh-huh.
So just to be safe, you think it was on the top?
Yeah, you would think this one, because this one is a downward parabola, this one's an upward. So if they're going to intersect, it's going to have to be like this, right? So then this one would have to be on top of it too. But yeah, what you said is also correct. A good way to check it. If you just wanted to double check to make sure on the interval, you could try plugging in 0, and 0 is 1 in this one, and 0 is -3 in that one. So that would be, yeah, both good ways to do it. So then setting it up, pretty easy then. We'll just find an area. A equals integral -2 f of x minus dx dx. Put parentheses around all of it with the dx is just good habit with notation. All right, next one we do have to sketch. So I'll give you a minute to go ahead and sketch number 7. So that's what your region should look like. And when you sketch it, if you can try to like make it proportional so where the intersect is correct. So like this would intersect at 4, sorry, at 2. Divided by 2. So 6 minus 2, which is 4, that's where that is. So that looks good for the region. And then we got to go ahead and find the area. So see that. That's in there. If you need to use the U substitution, yes you can. Or if you can just sort of figure it out. That's fine.
That's what I was doing the book.
Oh, okay.
Oops.
if you went the U substitution route, you end up with just basically nothing left over, right? Just becomes 1 dx. So just telling you, whenever that's the case, if you can just think ahead about that. There's not going to be anything you need to cancel anyhow, so it just becomes u to the 1/2, and then so it just becomes 3/2. And then obviously multiply, divide by 3/2, which becomes 3/4. And then just plug it in, 16/4. And then number 8, we're supposed to use this region and the volume of the solid form by using square cross sections perpendicular to the x-axis. So we're going to cut this into squares. What is that? What does this mean, like, as far as our setup? How's this going to change our setup? Our area. Or sorry, our volume.
It'll put it inside square.
Yeah, you basically just square it, right? Now it's volume, which makes sense that we have like another, so instead of just the function, we have the function squared, which is sort of like another dimension. Right, so exactly the same setup. Our side of this is just going to be represented by, this kind of goes back into the board or whatever, right? And our side represents the height and the depth of it. So it would then just be the volume, same integral, 2 to 6, which is then square root of x minus 2 squared. Which is then even easier because square and the square root cancel. So then find that volume, for example, 6 x minus 2 dx. Yes, 1/2 x squared minus 2x. Minus 12. Minus -2. All right, number 9, set up but do not solve these. So we're still on number 7 problems. Solid form by revolving the region about the x-axis. Okay, so it's going to be the same function then. It's just now volume, and this is just be the disk method then, basically, right? So we're going to take what we did here on the volume, and what's the only difference?
Put 5 in front.
Yeah, put a pi in front of that, that's it. This is just pi r squared, this is just side squared, but the radius and the side are the same thing. So if we were to write out, I don't know why we don't have to integrate it, because it'd be easy, I would have to lose pi on there, but anyway, pi out in front, 2 to 6, square root of x minus 2 squared, yes. So yeah, the 8 pi. We're going to actually figure it out. Alright, then if we want to revolve it around y equals 4, let's go up and draw it on there. Go on that line. So that's in the same quadrant. So then we got our outer is from here to here. So it's going to be washer method. So volume equals pi. Same limits, 2 to 6. If I want to do our outer radius squared minus our inner radius squared. So what is the outer radius?
The x-axis.
Yeah, so what is the outer radius? Not 0, no. Because we're going around the line y equals 4.
4.
Yeah, the distance from here to here is 4. Okay, so it's an outer squared. Before, and then what's the inner radius? Yeah. So 4 squared minus 4 minus. No, we don't have to solve that. That's a whole B solution here. Okay. Number 10, the base of a solid is the region bounded by that curve 1 over the square root of x. X equals 1, x equals 4, and y equals negative 3. Solid is formed by using rectangular cross sections whose bases lie in the region and are perpendicular to the x-axis, and whose heights are 3 times their bases. Set up an interval which represents the volume of the solid, and then use a calculator to find the volume of the solid. Okay, so we can use a calculator. Well, let's do that. Let's go ahead and get a picture of what this looks like first. So these 3 lines, are pretty self-explanatory, implying those x equals 1 equals 4, y equals negative 3. The actual function is the one you probably didn't know what it looks like. And if you graph it, on your calculator, does it kind of look like it just dead ends sort of into the axis there? kind of does, right? And it doesn't matter, but this one actually should have an asymptote. It should go up like that and go up to infinity. Because if it was just the function 1 over x, we know that goes up to infinity because as you get super small decimals, like if you think of like 1/10 of which would be 10, 1/100 would switch over to 100. So this is the same thing, it's just the square root, so it wouldn't grow quite as fast, but it's still going to be pretty big. So that's why we have these bounds here at 1 and 4. And then, so this is kind of a different region. The shaded area then is all of, normally we bound them by y equals 0. So this one's bound there by y equals -4. So kind of a different looking area, right? So we're supposed to now, a lot of words in this one, find the sol volume, represents the volume of the solid. Solid is formed using rectangular cross sections whose bases lie in the region and are perpendicular to the x-axis. So that's saying they go like this, right? And the height will, goes back into the board or out of the board, however you want to think of it, is 3 times the base. Does that kind of make sense? I know this is one of the harder ones that's to visualize that. But that's what's happening. So we got these rectangles up like this. The height is the function, right? And then the depth is 3 times the function. And the function being not just the function, I guess that's bad choice. The function is from here to here. Okay. So let's see if we can set that up. Let's start with volume. So V equals. What are our limits going to be? Okay. 4. And then we're essentially doing like our base times the height or length or width. So then it's just going to be actually just be 4 times whatever the function is, right? Because you got the function and then times 3 times it. So just 4 times whatever we decide this gap from here to here is. How do we find that? So if this is just 1 times the whatever we decide this is, and this is 3 times of it, it's just like the base times the height. So it's just the whatever we decide the function is or whatever times 3 times the function. Okay. So it just becomes 4 times whatever that is. And that's going to be, the function would just be this amount, but we need to add this extra. Yeah. So essentially just the function plus 3, right? Or the function minus -3. So either way you want to look at that, it would be 1 over the square root of x plus 3 dx. We can finish that part tomorrow. Just so you're still doing some practice, what I'd like you to do tonight is actually go back to the previous section, so the 8.4 assignment, and we're going to do some of these extra ones that we have here. So let's do, we did up through 10, right? So let's do like 11 through we did up to, well, I think in 8.4 we did up to 10, right? No, 8.4. Yeah. So let's do like 11 through, say 11 through 18. So 11 through 18, and that's page 202, right?
Yeah.
It's page 202.